Okay guys, how are you? I hope all is fine, and I'm just going to read out or actually share with you a concept from the books of abstracts, and that was actually the first student doctoral symposium organized by IIT Kanpur, the aerospace symposium, and there were some abstracts collected and was actually collected in the form of a book, and we have actually presented to you one abstract from that symposium in the previous video, just with the continuation of the same thought. The abstract, I have shared another abstract which has been about analysis of aerodynamic forces and in-flight measurements of an ornithopter. That is written by the Joydeep Bhaumik and Nidesh Raj and Dibopam Das. Number one, Joydeep is the PhD student at IIT Kanpur, and Nidesh is a research associate at IIT Kanpur, and Dibopam Das is associate professor at IIT Kanpur. The corresponding author's number is 919793430022. So you can directly contact and you can have the extended material if you want on any sort of the abstracts you want. The extended abstract, I just want to read out the details. If it's foggy or if it's not clear, just let me know. An ornithopter is mechanical replication of a bird which flies by flapping its wings. By flapping its wings. Lift and thrust is solely produced from the flapping of the wings, but unlike a fixed-wing aircraft, the aerodynamic forces and moments vary with time. The overall effect of these time-varying forces affects the kinematics of the vehicle, and essential to understand the same to develop such a vehicle into biomimicking stealth surveillance. UAV, which is the unmanned aerial vehicle carrying a camera. Theoretical analysis has been done and compared with some existing methods for a given wing with a given flapping kinematics. Force measurements on an ornithopter are also carried out in a wind tunnel, but since the model is rigidly fixed to the force transducer, the combined effect of the aerodynamic forces due to the movement of the vehicle flight is obscured. So the work presents an experimental approach to determine the aerodynamic forces that act on an ornithopter in real flying conditions. UAV nowadays have developed a lot. It is not difficult to see an autonomous aircraft of a rotary wing vehicle accomplishing complicated tasks without human control, but ornithopters, on the other hand, are at the developing stage, as the unsteady nature of aerodynamic forces offers a challenge in anticipating the same. The present study focuses mainly on the study of aerodynamic forces and moments that are generated on an ornithopter and their effect on the flight of the vehicle in a steady level cruise flight. These are the two graphs, which are cycle time, variation of thrust with the non-dimensionalized cycle time. You can have this in the thrust on the left side. This is the lift, which is the cycle per time, variation of lift with the non-dimensionalized cycle time. You have these two graphs in front of you. So by the lift and thrust combination and the cycle time, which is T by T. So this is how this abstract has been actually authored by these three PhD students, research associate and associate professor, and from IIT Kanpur, and I have shared with you a piece, actually a useful piece of information which maybe actually help us or eventually help you understand all about the aerodynamic, the forces, the in-flight measurements regarding an ornithopter. That is obviously a development as far as the technological development in the aerodynamic field is concerned. So I've just taken out so that we can understand what is going around till 2014, because a symposium was actually arranged on May the 2014. So obviously till that time, what was the development in this regard? So I have shared it with you another piece of information, a piece of writing, as well as the research the different scholars are concerned. So once again, I thank the respective scholars and also the institute for sharing this online. And I have actually converted it into text and on a paper so that I can complete and I can actually read out with authenticity and sharing some of the concepts and anticipating some of the comments from any one of you guys with the respective fields. So with these remarks, I'm going to end my video. Till the next, take care and have a nice day.